Regulated digital asset platforms need compliance built into every workflow, not added later. In this module, we'll connect identity, screening, transfer controls, monitoring, audit trails, and reporting into one architecture for safe issuance and defensible operations. We've already built the foundation: market context, platform choices, token design, settlement, custody, and regulation. Now we turn those inputs into compliance architecture: who is allowed in, what actions are permitted, and how the system proves it. A strong compliance architecture keeps sensitive checks off-chain, where identity, onboarding, sanction screening, and reporting can be governed and updated. The rules engine becomes the controlled decision point, rather than scattering logic across apps and contracts. On-chain systems receive only the outcome: eligibility, permissions, and transfer constraints. Each decision and exception feeds an audit trail, so teams can monitor activity, respond to regulators, and update policy without exposing personal data on-chain. In regulated digital assets, identity is the control layer behind every transaction. A verified profile may represent a person or legal entity and connect to wallets, roles, jurisdictions, risk ratings, and permissions. Sensitive identity evidence stays off-chain, while claims or eligibility markers can be used on-chain. For companies, verification also includes KYB, beneficial owners, officers, and authority to act. The model must handle change over time, including review, revocation, and audit evidence. Onboarding is where identity becomes permission. For individuals, KYC confirms documents, liveness, address, sanctions, and PEP exposure. For businesses, KYB validates registration, activity, ownership, beneficial owners, and signatories. These checks feed screening and risk scoring, which produce approve, reject, or manual review outcomes. Once approved, the platform binds verified wallets and issues eligibility claims for products, jurisdictions, risk rating, and review dates. Every exception becomes an auditable workflow event. Once identity is verified, the next question is more specific. Is this investor allowed to take this action? Eligibility combines accreditation, purchaser status, professional or retail classification, product suitability, and jurisdiction rules. Those rules may vary by asset, offering exemption, venue, and transaction type. The architecture should turn each decision into a reusable claim, with evidence, expiration dates, and revocation, so subscriptions, transfers, redemptions, and distributions are screened consistently. Beneficial ownership means looking through the legal wrapper to identify the people with ownership or control. That includes percentages, indirect holdings through trusts or funds, directors, trustees, signatories, and other controlling persons. Each party is screened for sanctions, PEP exposure, adverse media, document validity, and other risk signals. The architecture also needs refresh logic, so ownership changes or expired documents trigger re-verification, while permission decisions can use risk results without putting sensitive ownership data on-chain. Instead of rerunning full identity checks every time, the platform converts verified evidence into reusable compliance claims. A claim might say KYC approved, sanctions cleared, wallet verified, or eligible for a product. Each claim needs context: who issued it, what it applies to, how long it lasts, and whether it can be revoked. Personal data remains in controlled off-chain systems. Smart contracts consume only minimal eligibility signals using credentials, tokenized identifiers, selective disclosure, or zero-knowledge proofs. Think of the compliance engine as a shared decision service, not a feature buried in one application. Every channel asks the same core question: is this participant, asset, wallet, and transaction allowed right now? The engine combines identity, ownership, jurisdiction, sanctions, limits, holding periods, and transaction context. It then returns an actionable decision: approve, reject, review, freeze, escalate, or flag risks. Version policies and audit logs make those decisions explainable later. Transfer restrictions decide whether a tokenized asset can move from one wallet to another. For regulated assets, this control is not optional. The system may check eligibility, jurisdiction, caps, lockups, transfer windows, or blacklist status before a transaction is sent, during on-chain execution, or both. Strong designs do more than block transfers. They explain why a transfer failed, guide remediation, and preserve audit evidence for compliance review. A rule engine turns policy into executable decisions without locking every condition inside the token contract. For each transfer, it can check KYC status, wallet eligibility, asset limits, jurisdiction, sanctions, settlement state, and counterparty rules. The smart contract should still enforce the final gate, either directly or by verifying signed compliance attestations. Because rules can change, versioning, test cases, audit trails, and governance approvals are essential before any update reaches production. Sanction screening must operate as a continuous control, not a checkbox at onboarding. The program screens people, entities, beneficial owners, wallets, counterparties, and suspicious activity against sanctions, PEP, adverse media, and blockchain intelligence sources. When a possible match appears, teams score it, triage it, manage false positives, and escalate confirmed risk. Depending on the outcome, assets may be frozen or activity allowed, with evidence documented. Rescreening is triggered whenever lists, profiles, wallets, or events change. Effective AML monitoring for digital assets goes beyond transaction screening. It connects wallet behavior, settlement activity, blockchain exposure, platform metadata, custody events, and investor profiles. Alerts should be risk-scored in context: customer history, asset type, jurisdictions, counterparties, and typologies, such as structuring, mixers, or rapid redemptions. The workflow then turns signals into defensible cases with notes, evidence, escalation, filing decisions, closure rationale, and continuous tuning as criminal patterns change. Compliance does not end when a transaction is approved. The platform must prove what happened, why it happened, and which controls were applied. Travel rule workflows exchange required originator and beneficiary data. Reporting turns events into suspicious activity reports, transaction reports, sanctions reports, and audit packages. Immutable logs preserve policy versions, inputs, approvals, user actions, and exceptions. Regulator access should be controlled, read-only, and evidence-based, so supervision is transparent without exposing more data than necessary. The key takeaway is that compliance architecture bridges legal obligations and technical enforcement. Identity, eligibility, screening, transfer rules, monitoring, reporting, and audit need to operate as one system. Next, we connect these controls to security and assurance frameworks, then examine threat modeling and operational risk.